Hello, my name is Szymon. Currently I work in Allegro Group, and I would like to share with you some of my notions about testing in Python. I would talk a little about the tools we can use to test, about some patterns and some anti-patterns that we can see. But before we talk about how we should test, first we should answer a little different question, and this question is, why do we test our software? In my opinion, there are three main reasons that we need unit tests, that we need automated testing. The first is that we want to be somehow led in the development process, and we are led by our tests. The test-driven development is something that sometimes we believe there is no time for that, but there are reasons why this is very desirable. First of all, if we have some idea, we have an idea for a new module, for a new library, and this idea is very vague, then we can write tests, and by these tests we define our API. This isn't the formal definition, this isn't the narrative definition, but this is the definition by example. We write tests, we show some input, we get some output, and we can get an idea if this API is good, if our idea for this library is good. And then, after we define our API, we simply implement it. So we don't feel so lost. I don't know if you know this man, or if you have read his book. This man is the author of a very famous book called The Mythical Man-Month. And one of his notions here is that when we have always a working system, then the development is much easier, because we can see that our system works, it does something, it grows, it isn't built. We don't see just some skeleton, just some separate things. We see a working system. He says here that if the graphics system only displays a rectangle on the screen, then the efforts would redouble. And I think that if we put here, instead of even if it's only a rectangle, we put even if it's only unit tests, it would be just as true. I can tell you from my own experience that I once tried to do by myself an ORM, and it was quite a big project, and for a long time it didn't do anything. I couldn't use it anywhere. But because I had unit tests, because after every improvement, after every function I wrote, I could see this row of dots that appeared on the screen, I felt that I'm on a good way. So this is the first reason. The second reason is quite obvious. We want to prevent any damage, because we work in an iterative way. Our systems grow, we rather don't use a pure waterfall. Then when we add new features, we often break old ones. So to prevent the code regression, we write unit tests. We can, of course, use these tests with continuous integration. We can run these tests before we check in any code into the repository. I think it's most obvious reason why we need tests. And the third reason is that the tests are a kind of documentation. I think every one of you stumbled into the situation that you see a library and there is no documentation, or the documentation is outdated, it's vague, it's bad. You look into the code. The code is complete spaghetti. There are no docstrings or very little docstrings. But there are tests, and these tests are some use cases. In these tests, you can see that if you call a certain function with certain arguments, then you will get a certain result. So it is also some definition by example. You can see how to use the library. The narrative documentation can be vague, but the tests are always precise. You simply see it. This is the notion that is not new, because it was also put in the ancient times, that it's not words but actions that inspire people to follow. So if we can see how the system works, then we have a better idea about it than if we just read the narrative documentation. It's not that I tell you that we shouldn't write documentation at all, and in the end of this presentation I will show you how you can integrate tests and documentation together, because these are the things that like to play together very much. Okay, now let's look at a trivial problem. We have a function, the simplest one. It just prints hello world. It is trivial, but I think it's not so trivial to test, because when the typical test looks like this, you call a function with some arguments, and then you assert that the result is equal to something. This is the most common way of unit testing. Here you can't do it, because as you can see, this function has no return value. It always returns none. So we have to find some other way to test it. The first idea we can have here is to check if this print function was called. Because this is Python 3, then we can use the feature of Python 3 that print is just the function. In Python 2, it wasn't a function, and it was agreed that it was a mistake. But in Python 3, we can do something like this. I know that this is very complicated, but I will explain it first of all. And second of all, then I will show you how to do it in a very much easier way, because we have tools for it. Here we don't use these tools, because I want to show how it works. We create a class. This class is called mockPrint here, and it's a callable. It's callable objects. Its instances are callable because we define call here. We put here. We store arguments and keyword arguments. It doesn't do anything else. When we call it, it just remembers how did we call it. Next, we create a test case, which inherits from unit test case. We will use nose tests to run it, so we can use these setup and tear down functions, and this function, which begins with test, the nose test will recognize that it needs to first run the setup, then run the test, and then clean after itself with tear down. So in setup, we store the original, the built-in print function into the object, and we put into the built-in module our mock print. Then we test it. We call our function, and we assert that the arguments this function was called with are like this, the tuple containing only the hello world. And in tear down, we put print back. It is very important when we create some tests that somehow meddle with, for example, built-in module that we clean up after ourselves, because later someone might depend on the print function doing what the print function should do. So after we do it, we need to clean it. Even if this test fails, this teardown would work, so this is a safe way to do. But is it a good idea? This would work. This test would pass. It would really check if this hello world is correct. But there is one problem to this way of testing. Because let's say we redesigned our hello function and we didn't use print, but we used stdout write. This function would do exactly the same that the previous one. It would put hello world onto the standard output. But if we test it like this, it of course will fail because print wasn't called. So if we are afraid that this function wouldn't be called, but that the side effect would be the same, we can use another approach, which is a little harder, because in this case, we don't just mock the function, we mock the stream. I think every one of you knows what string IO is. This is a simple adapter that works as any IO stream, like file streams, like standard input, output, and so on. But it stores its value in a string, which you can get with getValue. And here we use our string IO, which we put instead of standard output. We call our function, and now we check if into this stream, because either the print function or sys_stdout didn't know that we put there, instead of normal stdout, some other thing. They would just blindly print it into what is under sys_stdout. And we can check there is hello world here. And it's also very important that we put the original stdout back, because if we don't do it, then everything would be printed into this object, and we of course don't want it, because other things, other test cases may depend on having the stdout correct. Okay. I see you all don't like all these playing with storing the original object, substituting, cleaning after yourself, and so on. We all know that we programmers are lazy. So there must be some easier, some lazier way to do it. This is something that is done often, so someone must have come with another idea before us. And the module that we can use here is called simply mock. The mock module is a set of tools that we can use to do some tests that require checking the side effects. Here is just a little interactive console, so we can see just how mock feels. We can create a mock object. We can access any attribute on a mock object, and it would be also a mock. So if you mock, for example, a module, then everything in this module would also be a mock. If we mock a class, then we can take any method of this, and it would be also a mock. And we can call a mock, and if we call a mock, it would do the same, that more or less the same that that function before did. It would store the arguments it was called with. So this is a more more professional, more rich way of doing what we've done before. And there is also a little decorator, so the thing we've done before looks very simple now. We decorate our function and we tell that we want built-in sprint mocked. This test function will add its argument, this new mocked print. Here we call this function and we use assert called with, which is also a tool from the mock module to check it. It is very, very simple, very clear. It's also safe because this built-in sprint would be only mocked here. If we want to use the other approach, the approach with mocking the string, the std out with string IO, we need to do it like this. Here we don't use a mock object, but we use this patch decorator. We provide here our own object that we need to use as mock, and we do it just as well, but we don't need to worry about setting up and tearing down about mock and cleaning up after ourselves. I will also show that the mock module have some other ways to use. We can mock the whole class if we want to have something mocked in all the functions, or if we want to mock something only in a block, we can use with. I don't know if all of you know what with is, because it's a feature that wasn't introduced in Python from the beginning, but it's very powerful because we can, it's in fact it's a syntactic sugar, but it looks very, very simple here. The sys std out would be mocked here in this block, and after we leave this block, we would get sys std out as it was original. Okay, so we have seen how to test functions that have side effects. Of course, the mock library is much bigger. It has a lot of more features. But of course, this isn't API reference. I just wanted to show you that we have such a good tool if we want to test some side effects. Okay, so we have another problem. We just created a subclass of dict that can count some stats. It can sum the values of the dictionary, and it can count the mean value. Okay, it looks easy. Let's say we create a simple test. And would this test work here? Does anyone know? Unfortunately, it won't. It looks like it's correct, but we use floating point here. So we will get floating point errors. We know that this module works correctly. Of course, if we can't tolerate this error, then we shouldn't use floating point, we should use something else. But let's say we tolerate it. But we need to test if it really works well. The problem is that we have too much precision. This test is too good, it's too sharp. So we should relax a little. In the standard library in unit test module, we have also a function called assert almost equal. We can control the precision here, and this would work. Of course, the problem of floating point operation is bigger than we can talk about here because these errors can propagate. But in this case, the default precision that assert almost equal gives us would work. But the floating point problem is one of the problems where we can deal with too much precision in our tests, where we sometimes need to make our test more flexible. This is something taken from a library that creates HTML forms. There is a form. We see here that it should render a representation for Dojo toolkit. We define some fields, some validators, and so on, and we want to check if this form would render correctly. For a long time, I believed, the first thing, we of course can't compare HTML as strings because this isn't equal this as a string, but of course these two HTMLs are equivalent. Every browser would display them the same, so we can't just assert equal and put the strings here. There is another idea. Let's use some kind of assertion that would compare HTML in some more intelligent way. That it would trim the white spaces. It would check if attributes in any order, and so on. And I always thought this was the good idea, but now I think that assert HTML equal, which is, for example, in Django, is harmful. Why? Let's say we improve our library and put some CSS class somewhere here. And now the test will fail. But as I said in the beginning, we have 3 reasons to write tests. The reason, second, was that we want to avoid breaking the existing functionality. But here, if we put some CSS class, we won't break the fact that Dojo would use Anthrax text box here. So in fact, we didn't break the backwards functionality. We didn't break anything, but the test fails. So I think we shouldn't use things like this. In fact, we would need assertions like this. These assertions aren't implemented yet, I think, in any reusable library, but we should assert that there is some table row. We should assert that there is a table cell that contains the word nickname. And even if something changes, then we still have this test pass. We should always test what interests us. We should test, for example, that this field would have this data Dojo type. As soon as that is here, we can do anything with this input element and don't break the fact that the JavaScript framework would use a correct representation. Okay, this is something for the future. Maybe it should land somewhere in LXML or some other or some separate library that we can do tests like this, that we can assert not that the HTML would exactly look somehow, but that it would have some features. Okay, and the last of the notions I would like to share here. I said something about documentation. Tests and docs like to play together. I needed to use this picture. Someone drawn me it on Doodle or Die, and I like this picture very much. So if it would haunt your dreams, I'm sorry. We all know about this built-in feature in Python. This is called doctests. It's very simple. It's very intuitive. We just put a part of interactive console into a docstring. And if we run this test, for example, if we use nose tests with doctests, it would check if this interactive console would work like this. And on the other hand, if the user looks on this docstring, he would know how this function works. So docstrings are some kind of documentation, some kind of example. They are some kinds of tests for our function, but they are also tests for a documentation itself. We need to know if we don't cheat our users. We need to know if it's really like we say, because if some user would see some examples and they won't work, we don't want it. But the doc tests are quite simple. They don't have many features, but there is some much more powerful way of testing your documentation. And it comes with Sphinx. There would be another presentation about Sphinx today, but here I would like to show you how we can intermingle tests with our documentation. We write some part of our narrative documentation, then we write some test code. Then we put some more narrative, then we put some more test codes, but here we also put test setup. And here, simple test code. And then we tell our user that this would produce something. And we put test output block. How would it work? If we compile this code into HTML or PDF or some other form for users to read, it would look like this. All this narrative documentation will be here. This thing would be hidden, this test setup. The user wouldn't see it. We don't want him. We don't want him to see this trick that we used pretty print here because it isn't part of the test case. We don't want this import because everyone knows what order did this. So this thing would be hidden. These things would be shown, and of course this thing as well. And if we tell Sphinx to test our documentation, it would simply execute everything. First this, then this, then this, and it would check if the output is correct. So this is, I think, almost literate programming, because we create something that is readable both by human and both by machine. So I think it's a very powerful tool, and tests written like this are, on the one side, they are comprehensive because they show examples, and on the other hand, we always can see if these tests didn't go outdated. So we can also take care of regression of our documentation. If our documentation somehow goes outdated, something would change in output of this, then we will get an error from Sphinx, and we would be able to correct this. I think that the doc tests or tests in Sphinx shouldn't be used as only tests. They should be used as a test for our documentation only. And we should use ordinary unit tests to prevent the regression of our code. Okay, these were the three notions I wanted to share with you. I don't know if you have any questions.
Are there any questions? Okay. First, sorry.
One question is why did you use the tear down method to do cleanups? Because as far as I know, tear down is not called when the setup method is called has failed. And so if you do some destructive patching in setup, you should rather use add cleanup. It is a new method in Python 2.7 and 3.1. It is one.
I knew that teardown isn't called when setup is broken. I assumed that this thing we do there simply can't fail, and thought it was safe. In the real world, I would always use the mock module because everything is done there by the module, so the developers of mock took care that it is safe. But honestly, I didn't know that this problem was addressed. I knew that there was a strong dispute. Should the teardown be called when setup fails? And I'm happy to hear it was addressed in some way. I didn't know about it. I got used to use mock module, so I didn't care about it, in fact. But thank you for this notion.
Is mock object you mentioned a part of Python standard library, Python 2 dot something or 3 point?
There is a mock library in standard lib in 3.3. Yes, from 3.3 there is a mock. I don't know if it has all the features from this separate. It has. It has. It is a part of. It is a part of distribution.
Okay, because I have just checked on Python 2.7 and the direct mocked import didn't work, so that's why I asked the question.
Yes, I didn't tell that you need to install it in some previous versions. But in Python 3.3 it is a part of standard library.
Yep.
I just wanted to clarify. In Python 3.3, it's unit-test.mock, and it's the same mock library with pretty much the same features, at least at the moment where Python 3.3 was released, because the independent library is progressing, and you can always install it with pip install mock, or add it just to your setup PY by test requires, and then it will work just fine. So,
working for this presentation was done with the one with PIP, the one installed with PIP.
Okay, are there any questions?
I got a question. If there is a special case when you would use doc test or Sphinx tests or regular tests, or that doesn't matter, or it's just
as I said, when I want to test my API, I want to test if my classes and functions behave as I want them, then I would use ordinary unit tests, and I would take care that they cover everything. And the tests in Sphinx, I would use, and the doc tests in docstrings, I would use when I want to show an example, when I want something that would be shown as well to someone who reads the documentation, and also, and this feature would be used then to prevent the documentation regression. So I know that the documentation is always up to date.
Okay, thanks.
Are there any other questions? Okay, thank you very much. Szymon.
Thank you. There is one more thing, because there would be on my workshop, there is a mistake in this description. It is said you need I think PsychoPG and Pyramid for this. I changed it a little, but I forgot to change the description. All you need there in your virtual env is LXML, because we would store the values in LXML there. The subject of this workshop would be the same, just the illustration would be different. Thank you.
Okay, thank you very much once again.